Hey, what's up YouTube? Welcome back to Intuition. Today's video we're going to be going over coordinate systems and how to give directions mathematically. All right, stay tuned. So in today's video we're going to be answering 3 math questions on coordinate systems. Coordinate systems are just mathematical ways of giving directions. Coordinate systems are at the heart of how a lot of things work, right? Especially something like GPS, which has to keep track of where you are in relation to your destination at all times, right? So coordinate systems are very important to be familiar with, and it's a very broad and general topic in math, but everybody should at least be familiar with the simpler coordinate systems that are most widely used. Okay, so with that said, let's dive into these questions. All right, question number 1. Question number 1 says, you live in a city with a rectangular structure where all the roads run along the east-west or north-south direction. If your favorite restaurant is located 3 blocks west and 4 blocks north of your home, identify the proper coordinates for the restaurant's location. So this is a very easy problem, but you need to be familiar with what rectangular coordinates is. And it kind of says it in the name, right? Rectangular coordinates would be a rectangular coordinate. So it's basically a coordinate system that is laid out like a rectangle, right? So let's take a look at what that would be. The city has a rectangular structure and all the roads run along the west-east direction or the north-south direction. You have roads that intersect at 90 degrees. That's what a rectangular coordinate system is. So if you have a city that's shaped like a grid, like a rectangle, then this is the perfect coordinate system to use. Now, when it comes to giving direction, you need a reference point, okay? And the reference point is called the origin, right? So that's the 0 point on this rectangular coordinate system here. You can't give directions without first agreeing on a specific location. So you need to start at the same place, and then you give direction from that place to the other place that you're interested in going to. And in this case, we're going to use the origin to be a reference to your house. So your house is located at the origin and your restaurant is 3 blocks west and 4 blocks north. So now when it comes to giving direction from the origin in a rectangular system, if you are moving to the left, left means negative. You're headed in a negative direction mathematically. And if you're moving to the right, you're heading in a positive direction. This is completely arbitrary, but this is the convention in math. To the right is positive, to the left is negative. And same thing with up and down. If you're going north, you're moving in the positive direction. If you're going south, you're moving in the negative direction. So in this case, your friend's house is 3 blocks west, which means that it's 3 blocks in a negative direction. So we're going to move -3 along the x-axis. And then once we have moved -3 along the x-axis, we stop and then we head north, right? Because your friend is 4 blocks north of you as well. So now we walk 4 blocks up and we're moving north. So we're going in the positive direction. So that would be +4. So the coordinate system would be -3, +4. That's how you would give direction in this rectangular coordinate system. So our answer choice would be -3, 4. That would be the location of the restaurant. Very easy, I told you. Let's go on to question 2. Question 2 says, in reference to your neighborhood park, the rectangular coordinate system for your home is 1, 1. What is the corresponding polar coordinates for your home? Let's make sure we understand this question. We have moved the origin from our house over to a park in our neighborhood. So the park is the reference point. In reference to the park, our home is located at a point 1, 1. So to get home from the park, I would have to walk 1 block east and 1 block north. Now we're being asked to identify this same point, to identify our house in polar coordinates instead of rectangular coordinates. What is polar coordinates? What does that mean? Think of polar coordinates as circular or spherical coordinates. In 2 dimensions, it's going to be circular coordinates. So polar coordinates would be perfect if your neighborhood is laid out in a circular fashion. Like maybe if there's like a big monument at the center of the city, and then all the neighborhoods are built in circles around that monument. So that's what polar coordinates would be like. So to give directions in polar coordinates, we still need to have a reference point. So that would be the point in the middle. In this case, it'll be the park. The park is the reference point in the middle of the neighborhood. So the neighborhood is going to be circles around the park. So to identify where you live in this neighborhood, we first need to know which circle that you live on. And all of these circles can be given in terms of one number called a radius. So the first piece of data we will need is the radius, because we need to know which circle do you live on. Do you live on circle 1 or circle 2 or so forth, right? And all we will need is R to identify the circle that you live on, because a circle is perfectly symmetrical and the distance from the center of the circle to the edge of the circle is going to be a constant number all around the circle. Once we identify which circle you live on, we need to know where on that circle you live, because you can live anywhere on that circle. So all the roads are circular, but then we would need a different type of road to be able to get us from one circle to another, right? If all they had was circular roads, we'd be stuck on a circle and we would only be able to move along a circle. So we will also need radial roads to be able to connect us from one circle to another. And radial roads are identified by a variable called theta, which is the angle. Now the reference angle is the angle that corresponds to the road that runs east from the origin. The road that runs perfectly east from the origin is called angle zero road. So that's theta equals 0. So these roads are going to be identified by the angle. So a road that runs perfectly north will be a road that corresponds to an angle of 90 degrees. So every radial road is going to correspond to a specific angle. And this is what polar coordinates will correspond to. So now in this problem, we're being asked to convert from rectangular coordinates to polar coordinates. So we're going to go from XY values to R theta values. And how do we do that? So in a rectangular coordinate system, your house was located at a point 1, 1. Now to convert this coordinate system to a polar coordinate system, we need to know what circle does your house fall on. So we draw the circle that your house falls on. And we ask, what is the distance from the park at the center of the circle to the circle that your house is on? You get this distance by using Pythagorean's theorem. It comes from a right triangle. So you can take the distance r to be the hypotenuse of a right triangle with a base of 1 and a height of 1. Because the base of this triangle would be the x value, which is 1, and the height of the triangle would be the y value, which is also 1. Pythagorean's theorem says that the hypotenuse squared is equal to the base squared plus the height squared of a right triangle. So now all we have to do is just plug in, right? We know that x is 1, so that's 1 squared, plus our y coordinate is also 1, so that's 1 squared. So that's 1 squared plus 1 squared, which is equal to 2. We have r squared equals 2, so what we need to do is we need to take the square root of both sides. So when we take the square root of r squared, we get r, and we take the square root of 2, we get the square root of 2. So that's radical 2. All right, so we have one part of our coordinate system. Now we need to find the theta. When you have a right triangle, if you take the tangent of an angle within the right triangle, the tangent is going to be equal to the opposite side divided by the adjacent side. For the angle, the adjacent side is the x value, which equals 1, and the opposite side is the y value, which also equals 1. So we have a tangent of 1, and what angle corresponds to a tangent of 1? So that angle is going to be the angle for which the inverse tangent of 1 is equal to that angle. And the inverse tangent of 1 is 45 degrees, or pi over 4. The location of our house in polar coordinates will be equal to radical 2 pi over 4. And the answer will be answer choice A. All right, let's go on to question 3. So question 3. A city is designed in such a fashion that makes UV the natural coordinates for position designation. The coordinates U and V are defined as U equals Y minus X and V equals Y plus 2X. What would be the best description of this city? This one is more advanced, right? So if you can figure this one out, I say you're doing pretty well. But if not, let's go ahead and figure it out together. Now remember, when it comes to coordinate systems, they're completely arbitrary. You can pick and you can create any type of coordinate system that you like. You want to choose the coordinate system that best works out with the layout of the environment that you're analyzing. So if you're analyzing a city or an area that has very circular roads and circular systems, then you want to use polar coordinates. If the layout of the system that you're analyzing is more grid-like and rectangular, then you want to use rectangular coordinates. Now we're being given these two different coordinates and we're being asked to find, well, what type of structure would these coordinates best correspond to? The best way to find that out is to plot this coordinate system and see what the layout looks like. So let's go ahead and plot the coordinate system. So for these coordinate system, if we go ahead and solve for y, for the u value, we get y equals x plus u. Y equals x plus u, that's a straight line with a slope of 1. So these rows are just straight lines. Now we go ahead and draw the rows that corresponds to a specific v. If we rearrange this equation and solve for y, we get y equals negative 2x plus v. Again, this is another straight line, right? Remember, equation of a straight line is y equals mx plus b, where m is a number and b is a number. In this case, this row corresponds to roads that have negative slopes, and it's a negative slope of 2. So this is what the city will look like. And now, when you look at the structure that these roads form, they don't form rectangles. They don't form rectangles because their slopes are not are not opposites of each other. By opposite, I mean inverse. We have roads that run in the slope of 1, and then the other roads run in the slope of -2. 1 and -2 are not inverses of each other. So therefore, these roads don't intersect at right angles. They intersect at angles other than 90 degrees. And if you have two roads that intersect at an angle that is different from 90 degrees, they're not going to form a rectangle. They're going to form a parallelogram. And just by looking at this picture here, you can see that the structure that these roads form is they form parallelograms. They don't form rectangles. So when you go ahead and look at the answer choices, it's a parallelogram sitting. So the answer is answer choice C, parallelogram sitting. You form parallelograms when you have intersecting lines that intersect at angles other than 90 degrees. All right, so there you have it. I hope that you guys learned something from this video. This is more of beginners to coordinate systems, but we're gonna get more advanced. So go ahead and make sure that you understood the concepts that we covered here in today's video. And if you have any questions about anything covered in this video, you can go ahead and leave it in the comment section below. All right, so keep watching, keep learning. And as always, I'll see you guys next week. Bye-bye.